raised from the ceiling and held at a small distance apart shown in the diagram below. So we know that we have positive 4 times 10 to the minus 18, and then a negative. We don't know what our negative is. So we've got positive and negative charge. Alright, sphere X carries a charge of plus 4 times 10 to the minus 18, while sphere Y has an excess of 30 electrons. So remember, when I get a physics question, what's my first step? Underline my numbers. Alright. Calculate the magnitude of the charge on sphere Y. So how do I calculate the magnitude of the charge on sphere Y? Magnitude means amount. Right, magnitude means amount. Yeah. So 7.1, we'll start over here. Q is equal to N QE. My charge is what I want to know. Is equal to 30 times minus 1,6 times 10 to the minus 19. Gives me an answer of Alright, gives me negative 4,8. 4,8, just give me a sec, times 10 to the minus 18. Yeah.
And what does net?
Net means average. Average, yeah, that's what net means, average. Alright. So guys, the spheres are now released and they move towards each other. Okay. Give a reason why sphere and X and Y move towards each other. Opposites attract. Alright. Don't forget your units. Opposites attract. Alright. The spheres are allowed to touch each other. After touching, they move away from each other. State the principle of conservation of charge in words. The charge of an isolated system remains conserved. Yeah. You've got it on your definitions. Okay? You learn your definitions. We know this. We've been writing down our definitions since we were forever. Okay. How would the charge be distributed on the spheres? Uniformly or unevenly? So it would be uniformly because it is a circle. Okay. Not particularly important for IEB, but the charge would be distributed uniformly, just so you guys know the answer. Alright, 7.3. Uniformly. It is a sphere. A sphere has a regular shape. Alright, so now, calculate the charge on each sphere after they have separated. Alright, so now we need to calculate the charge on each sphere after they have separated. So 7.4. Q is equal to my Q1 plus Q2 over 2. And now I say 4 times 10 to the minus 18.
Where do we get that stuff? What about the electrons?
Alright, where do we get the 30 electrons? Alright, so guys, I calculate that and I divide it by 2. Remember to include your negative.
And it's negative 9,6 times 10.
So 4 times 10 to the minus 19.
Ma'am, how do you know that Q2 is negative 4,5?
4,8 because I calculated it over here.
But then that, okay.
Alright guys, so what I'm doing is I calculated my charge on, here I calculated the magnitude of charge on sphere Y. So this doesn't necessarily have to be 1 and 2, this can be X and Y. Alright. Then they touch and they move apart, so I calculate my new charge in each of the spheres. Alright, so now I want to add a 7.5. Alright, so it's now 7.4, I want to add 7.5. Were the electrons transferred from X to Y, or Y to X? Which direction were the electrons transferred? Alright.
Yeah, it's too wide.
Okay, so guys, the electrons were transferred. So now what I'm going to do is I'm going to say this started at positive 4 and came back to negative 0.4 times 10 to the minus 18. This started at negative 4.8 times 10 to the minus 18 and ended at negative 0.4 times 10 to the minus 18. Okay? So this is our beginning value and our end value. Our beginning value and our end value. Alright, so if electrons are negatively charged, which one got more negatively charged, which one got less negatively charged?
X got more negative.
X got more negative, right?
So it's from Y to X.
So it's from Y to X. Alright, so it always gets transferred from the negative one to the positive one. Alright, so it's transferred from Y to X. Alright, and then we're going to add a reason for ourselves. They won't ask you for a reason in the exam, but a reason for ourselves so you guys can remember. Alright, because X got more negative, Y got less negative. Does that make sense?